प्यारे बच्चों, अब हम लोग नेक्स्ट जो प्रॉपर्टी है फीडबैक की, इसमें बैंडविड्थ एक्सटेंशन की बात कही गई थी। किस तरह से फीडबैक यूज करके हम लोग बैंडविड्थ को बढ़ा सकते हैं। इसमें दिस इज द वन मेजर प्रॉपर्टी ऑफ द नेगेटिव फीडबैक। सो बैंडविड्थ सबसे पहले हम लोग समझेंगे कि बैंडविड्थ क्या होता है, किस तरह से एम्पलीफायर में बैंडविड्थ को डिफाइन करते हैं, जिसमें वाई एक्सिस पर हम लोग गेन लेंगे डीबी में और एक्स एक्सिस पर हम लोग फ्रीक्वेंसी लेंगे। दिस इज द लॉग फ्रीक्वेंसी। Generally, gain curve is like this, in which this is the mid gain. This is called the mid band gain, and we have two frequencies. One is called the upper 3 dB, and this is called the lower 3 dB. So omega h is the upper frequency, upper 3 dB, and this is the lower 3 dB frequency. So these are two frequencies, and this range from here to here. So bandwidth is defined as upper minus lower 3. So this is the bandwidth of the amplifier. If upper 3 dB frequency is omega h and lower 3 dB frequency is omega l, then this quantity bandwidth equals omega h minus omega l. By using feedback, when we are using feedback, then upper 3 dB frequency increases. Actually this shifts towards right. So by using negative feedback, this omega hf is the upper 3 dB frequency with feedback. Similarly, lower 3 dB frequency, this is called the omega lf. So this is the lower 3 dB frequency, and lower 3 dB frequency is reduced by using feedback. So obviously when upper 3 dB frequency is increased and lower 3 dB frequency is decreased, then bandwidth with feedback is given by omega hf minus omega lf. So range of this frequency is increased by using feedback. Now we can show how this increases by using feedback. So this is the basic concept of bandwidth. This is the bandwidth without feedback, and this is the bandwidth with feedback. Now we will show how this bandwidth increases when we are using feedback. So we can mathematically show this concept. By using feedback, upper 3 dB frequency is increased and lower 3 dB frequency is reduced. So we have three equations. One is for high frequency. For high frequency, gain is given by gain, which is the function of frequency, is given by s upon omega. Suppose this is equation 1. This is for high frequency, and for low frequency this expression for gain is like this: 1 plus omega L upon S. Suppose this is equation number 2. And another expression for gain with feedback is given by, suppose this is the gain with feedback, which is function of frequency. This is the gain without feedback upon 1 plus beta times of AS. So this is the third equation. These are three basic equations. By using, we can show upper 3 dB frequency is increased and lower 3 dB frequency is decreased. Now putting this value from equation 3 and 1, we can show that AS equals AM divided by AS, this is 1 plus S upon omega H, and another equation is this: AF equals AS upon 1 plus beta S. We are using these two equations. If we put this value of AS in this equation, then we can write gain with feedback can be written as midband gain whole divided by 1 plus S upon omega H divided by 1 plus beta AS. AS means this quantity, AM upon 1 plus S upon omega H. After manipulating, we can write this equation. If we take LCM here, then we can write AM upon, here this is multiplied 1 plus S upon omega H plus beta times AM, or we can say this is the midband. So this is the expression for this. After adjusting, so we can show that this upper 3 dB frequency can be increased. From here, we can write this is the gain with feedback, and after adjusting, we can write this is the AM. We can take this common, 1 plus beta times AM, take this common, then remaining part can be written as 1 plus, this is the S upon omega H, and this factor comes in denominator, 1 plus beta AM. Or we can write also AM divided by 1 plus beta AM whole divided by, this is the 1 plus S upon omega H 1 plus beta AM. Or we can write AFS equals this term in numerator can be written as mid-band gain with feedback, and this whole term in denominator can be written as upper 3 dB frequency with feedback, where this quantity. Gain with feedback is given by this one, means original midband gain divided by 1 plus beta m. So obviously midband gain using feedback is reduced by this factor. This factor is called the amount of feedback. And what about upper 3 dB frequency? Upper 3 dB frequency is increased by the same factor. So upper 3 dB frequency, that is omega HF, using feedback is increased by this same factor. So this is one part, means upper 3 dB frequency is increased. Similarly, by using other two equations, we can show that lower 3 dB frequency, that is omega LF, is reduced by the same factor. So this is the lower 3 dB frequency which is reduced by this factor, and this is the upper 3 dB frequency which is increased by this factor. So now we can show that this factor. So this is one part where we have shown that upper 3 dB frequency is increased. Now come to the second part. To show remaining part, we can use other two equations, means gain for the lower frequency response. So now we will focus on this, how we will show that lower 3 dB frequency. So for this we will use the gain for lower 3 dB is given by this midband gain upon 1 plus omega L upon S, and gain with feedback is given by gain without feedback upon 1 plus beta S. So by using these two equations, we can show that now AFS equals, AS means AM divided by this 1 plus omega L upon S whole divided by 1 plus beta AS, means this factor, AM upon 1 plus omega L upon S. So after solving, gain with feedback, when we will take LCM of this term is cancelled out, and we can write AM upon 1 plus omega L upon S plus beta M, and we can write this like AM upon, if we take common 1 plus beta M, remaining part is like this 1 plus, this is omega L upon S into 1 plus beta M. Again we can write this AFS equals, this is the AMF divided by 1 plus, this is omega LF upon S, where we can write from here this term AMF, this is the midband gain with feedback, and this is the this part, this one, AM upon this, means AM divided by 1 plus beta M, and this term omega L upon this quantity, this is the lower 3 dB frequency with feedback, means omega L upon 1 plus beta M. So from here we can show that this lower 3 dB frequency is reduced by this factor. So now we can say that by using feedback, upper 3 dB frequency is increased by a factor which is called amount of feedback, and lower 3 dB frequency is reduced by the same factor. So now, so after and before, so this is the bandwidth without feedback, and this is the bandwidth with feedback. We can say this is the bandwidth without feedback and this is the bandwidth with feedback. Means here this is the lower 3 dB frequency. After using feedback, this lower 3 dB frequency is reduced. Means this shifted towards left. And this is the upper 3 dB frequency without feedback. After using feedback, this increases, means shifted towards right. So this bandwidth can be increased by using negative feedback. So in this way we can easily show that by using feedback, bandwidth is extended. So this is one major important property of negative feedback. Means by using negative feedback we can achieve more bandwidth for amplifiers. Means our amplifier is improved for working with feedback. So this is one property. So in next topic we will discuss other properties of the negative feedback. Okay, thank you. This is all about the bandwidth extension.